Well, hello and welcome. This is Lawton Snyder with the Ioneer Foundation, but I am here really with the nice privilege of being able to introduce some of the ophthalmology faculty here in the Department of Ophthalmology at the University of Pittsburgh. And today I'm introducing one of our newer faculty who I'm pleased to say came on with the help of one of our local funders, the Richard King Mellon Foundation, that gave us some support to bring in teams of scientists who are working in visual cognition. So welcome, Dr. James Herman, Assistant Professor of Ophthalmology in the Laboratory of Visual Cognition at the University of Pittsburgh School of Medicine. Dr. Herman, thank you and good to see you.
It's my absolute pleasure to be here speaking with you.
So, right away, I mean, I think there's got to be a question here as far as how does someone get into something like understanding the brain and visual science of the brain. I mean, obviously you had an interest in science coming up as a kid and decided to go on a path to get your PhD, but tell us about that process and what led you to what you're doing today.
Sure. So you hit the nail on the head. I've been interested in science since I was very young. My interest in those kinds of things, in technical matters, began with my love of math at a very young age. I just loved being able to solve puzzles and being able to find answers to questions. That turned into a love of physics when I was in high school and college, and I thought I was really going to go down the path of trying to get down to the finest grain puzzles of the universe. But around that same time, I was introduced to neuroscience by a very good friend, someone I'm still very close with. And she presented me with a number of puzzles that the brain solves. I remember one of the early ones was, how do we use our ears to localize sounds? Sounds feel like they come from somewhere, but that's not a trivial problem. If you just have two microphones and you try to answer that same question, it turns out you kind of can't. So the brain has figured out how to solve something that I realized was highly non-trivial. And that was really the beginning of my interest in the brain, was realizing that these problems that we solve in our everyday life, just to move around the world, just to interact with one another, are really quite complicated. And many of them are totally unsolved. We don't know how the brain does them. We know the brain does them, but we don't know how the brain does them. So that was a big part of it, was just realizing that there were a number of open and interesting problems to be solved. As I said, I really like puzzles, so that seemed like a good fit. But the other component was I loved the idea that I was studying something, or that I could be studying something that other people could relate to. Everyone, I think, as they in their daily lives experiences some of the things that I like to study, or they make use of some of the abilities I try to understand. And so being able to relate to other people and to their experience and to my own experience quite directly was just a huge bonus. So I got to, I get to solve puzzles. I get to use all kinds of fancy mathematical tools, computational tools, cutting edge biological tools, obviously, but I also can sit down with someone and, give them examples from their own life that are related to the kinds of puzzles that I like to solve. So for me, that's a perfect combination.
So what puzzle are you working on now? What are the things that you're trying to solve that relate to your work here in the visual cognition lab?
Yeah, so there's a few, but I would say the top one is, how do we learn in any given circumstance? How do we learn what parts of the visual world are important and what parts of the visual world aren't important? So if you're sitting at a traffic light and you're deciding whether or not to put your foot on the gas, it's pretty obvious what the relevant visual information is for you. You're looking at the traffic light. You're checking to see if the color of the traffic light has changed. Of course, there's a number of other things you're curious about. You want to make sure, there's no other dangers, nothing else in the road, but you know where the relevant visual information is. And so that makes it much easier to guide your behavior. You don't have to figure out what to use in order to guide your behavior. You can just focus on sort of deciding when to deploy that behavior of pressing your foot on the gas. But if you find yourself in a novel circumstance or somewhere you haven't been before, let's say you are trying to get a cup of coffee in a foreign country that you're visiting for the first time. Maybe you can find a coffee shop. I think, maybe just by following your nose, you could find a coffee shop. But you walk into a coffee shop. What are they selling? What does it cost? What's available to you? Where do you even figure that out? Particularly if you can't read the language, but any sort of novel circumstance like that, you need to sort of do a first pass of what information will even tell me what I want to know. I'll give you one more example, which is I love play. So play is a universal phenomenon amongst mammals. We see, you mentioned that your dog might sneak into the frame. Puppies play, humans and dogs play. We see all kinds of, young mammals engage in play all the time. And one of the interesting things I think about play, particularly amongst humans, is that you can make up a game very quickly. And what I mean by that is you might see a couple of kids saying, let's run to that line over there. And the first person there wins. So what has happened is they have decided that there's some arbitrary visual feature of the world that is going to serve as a guideline for what they're doing. And this is effortless. They've just assigned some meaning to some bit of visual information out in the world that has no inherent meaning. And it certainly doesn't project its meaning to them. They've assigned that meaning and agreed on it, and they can they can easily agree, oh, you were first, you got there first, or I got there first. So all of these things involve either learned meaning in the case of the traffic light, or a situation where you need to quickly learn the meaning of visual information out in the world when you're in a coffee shop, or just another example of how we routinely, quickly assign and learn new meanings for visual information out in the world. And this happens so automatically and so rapidly that it somewhat defies our understanding of structural connectivity in the brain. And so what I mean by that is, we know how the brain solves certain kinds of visual problems, like recognizing certain patterns, or being able to identify a face, let's say, or discriminate a face from another type of visual stimulus, visual object out in the world. But reconfiguring the visual system rapidly in this way where, I can describe a meaning to you that we're going to assign to some visual stimulus, and then you can instantly change your behavior and guide your behavior on the basis of that newly assigned meaning, is something that defies explanation. And so this process is something I'm really, really fascinated by. And it's a question that I have tried to make tractable by focusing it down in particular ways. So a very specific way that we assign meaning to objects out in the world is with something called visual attention. And so this is closely related to what I've been talking about, that certain information is relevant and certain information is not relevant, depending on the context we find ourselves in. And we know what happens in the brain when you interpret something as relevant or irrelevant. Broadly speaking, the amount of brain activity that's evoked by something you interpret as relevant is greater than the amount of neuronal activity that is evoked by something that you interpret as irrelevant. So there's a clear distinction there, which is nice because we want to have nice, easily quantifiable ways of saying this is the meaning of this and this is the meaning of that. But now, so once we have that canonical mechanism of sort of labeling something as interpreted one way or the other, now we can start to ask the question of what type of experience allows a stimulus to undergo a transition from unknown to relevant or irrelevant, because we can clearly label the activity in the brain as being corresponding to something relevant or irrelevant. Okay. Now I can simply say, all right, well, what are the other brain areas? What are the brain areas outside of the visual system where we know those visual signals are being interpreted and represented by the brain? What other brain areas are supporting this kind of interpretation ability? And what kinds of experiences lead to something being interpreted as relevant or irrelevant? So this is the major experiment I'm engaged in right now, is trying to train animals to interpret visual stimuli as relevant or irrelevant, and then looking at the brain activity that corresponds to those visual stimuli, tracking them over time while they're learning, and trying to relate that back to specific brain areas that support those kinds of abilities.
Is part of the hypothesis also related to when someone is losing vision, that some of those abilities to to understand and cognitively interpret those experiences may change?
So absolutely, there's a great amount of redundancy in the brain, and we know that there are multiple visual pathways from the retina to the brain, and so it's well known that. For example, there's a phenomenon called blind sight, in which patients that don't have cortical vision nonetheless are able, at better than chance levels, to report some aspect of a visual stimulus out in the world. So they will tell you that they're guessing, but you can see that there is actually some visual information reaching the brain. And so those kinds of questions are extremely relevant for understanding what the contributions are to those kinds of processes where you're making use of vision. And I would say beyond that sort of example of simply a blind sight, the question of, as if vision is lost, how those functions are, how functions like attention or guiding of behavior based on whatever visual information remains is fundamental, because those processes are likely engaged all the time. So what I mean by that is, a central part of my hypothesis is that we don't learn to interpret visual information once and then never again, but that we learn and relearn to interpret visual information throughout our lives. As I mentioned earlier, children do this effortlessly. If you learn a new sport, you're going to have to learn the meaning of new visual information that you haven't encountered. This is something that we do all the time, is encounter new visual information and learn what it means. So I think that those who are losing vision, it's likely that when vision loss occurs, initially it's not noticed because there is such plasticity and redundancy in the brain that those mechanisms of learning to use whatever visual information is available are kicking on and right, doing whatever they can to compensate for any sort of loss of vision. So absolutely related to loss of vision. If I may say one more thing about this, also related, I think, to gain of vision for the same reason. So if visual information is supplied to the brain in some new way, so there's a wonderful example of an article by Dr. Oliver Sacks, where he worked with a patient that had had cataracts for, I think it was 20 years, and had them removed after 20 years. And so this patient had effectively been blind for a very, very long period of time, and then all of a sudden had their sight restored. And they didn't really know what the visual information meant. This individual, and the example that I remember very clearly reading about this case is that the individual had pets, and their cat, this individual's cat, walked into the room, and the person had no idea what it was until they reached out and touched the cat. So touch had become far more important for discrimination of objects in the world. But over time, the person was able to relearn to use their visual information and to, reincorporate it into their normal daily routine. So I think that the relationship between learning and interpreting visual information and the gain of vision, the loss of vision, these are all fundamentally intertwined issues. So anytime we want to think about what happens when someone is losing vision or we can restore vision, we have to understand how to help them make use of that visual information, how to best learn to make use of the visual resources that they have.
That's fascinating. Because I think of your work and others that are going on in our cognitive vision area, and I often think of the things I know that are sort of the moonshot goals of having a cortical visual neuroprosthesis, which certainly I know that that's part of where your work can apply. But yes, I see that for people who have their vision restored, which we're now doing, for certain conditions with vision loss, some genetic vision loss, some conditions related to that will be affected by some of the devices and other things that the teams are working on. How does that impact relearning vision or restructuring the brain that's already been rewired to not have vision? That's really fascinating.
Yeah, thank you. I find these questions to be endlessly interesting. It's a challenge to translate them into a purely scientific setting, but I think it's made somewhat easier to do that by the environment in the Department of Ophthalmology, where we're working hard to bring the clinical and the research sides of ophthalmologic research together, which I think is vital for solving these kinds of problems.
Would you see anything that's potentially exciting in the near future for patients or for anybody who would be interested in understanding how we're applying this work to potential clinical use in the future? Anything that is on the horizon?
So this is something that we're working hard on. So this is something that this is a big part of why I was lucky to join this team, is that this is a major goal of ours, is, as you said, the cortical visual prosthesis. And so we are extremely hopeful that this is going to be a problem that we are tackling in human patients very, very soon. There's a number of things that remain to be understood, but it is my hope that at least methods of training that can help optimize the use of visual information for people that have some vision loss or have had rudimentary restoration of vision is going to be something that's going to be available soon. So I'm surprised that this is not something that's already available. So wow. There are applications beyond. There are applications outside of the clinical ones in which people have vision loss or vision restoration, because experts often have visual abilities that trump those of novices. And so I'll give you an example, which is if you are a surgeon and you're performing some sort of surgical procedure and you've done it many, many, many times, then you know that there are certain visual signatures that you can identify that tell you something about the tissues that you're working on, that tell you something about the condition of the patient, the health of the patient. Before you've done those kinds of surgical operations a number of times, of course, that information is not available to you. You don't really know what to look for. So this is an example whereby there's a very clear trajectory from less experience to more experience, and that experience endowing specific visual cognitive abilities. And so this kind of process of developing training programs that are specifically aimed at that kind of trajectory, I think are likely to be available very, very soon, particularly because these kinds of experiments aimed at developing those kinds of therapies are non-invasive and can be engaged in by anyone. So this is something that I'm actively working on presently with another member of the faculty of the Department of Ophthalmology, J. Patrick Mayo, and some outside collaborators as well, to try to understand how we can help people make better use of vision.
That's really phenomenal. And I think I love your example of a surgeon, because yes, the cognitive, impact that vision has in terms of what they're seeing and how they're operating, and there's so much involved in that. And certainly the learning aspect of it is also something that you can really relate to. So fantastic. Well, your work is amazing. You're certainly doing things which we're all excited about here. And you're new to Pittsburgh, so welcome. Maybe just tell us a little bit about that. I mean, you just moved here a little over a year ago, right? And
it's just about, it's like a year and 3 days.
So okay, yeah. Really little over a year ago.
Yeah.
So how's it going? Adjusted well? And
so my wife and my young daughter, I have an 18-month-old daughter, and my wife moved to Squirrel Hill in Pittsburgh a year and 3 days ago, and we absolutely love the city.
Great community.
We're finding it incredibly welcoming, incredibly friendly, and a really, really lovely place to live. We've been, of course, slowly, as pandemic life dictates, we've been exploring just a little bit, but we've been enjoying, we're now, I would say, relatively frequent visitors to the National Aviary. We find it incredibly peaceful and beautiful place to go and spend an afternoon.
Yes.
We love the Phipps Conservatory. My daughter is, she can't wait until it's warm again out so we can do some more exploring, but she doesn't mind. We just got bundled up this past weekend, and she had a grand old time walking around the neighborhood and saying hi to everyone she saw, including all the dogs. She has to say hi to all the dogs. So we're absolutely loving Pittsburgh so far, and just looking forward to exploring it further and getting more into it.
Wonderful. Well, thank you for making Pittsburgh your new home, and thank you for joining this team. We're all very excited. We're very excited about what you collectively can do as a team, and it's really neat hearing about what you're working on individually. And I'm looking forward to getting more opportunities to spend time with you and learn more about the work that you're contributing to. And thank you for spending time with us today.
Thank you so much. It's absolutely my pleasure. I am overjoyed to be here, part of this team. I can't imagine a better place to do this kind of work.